and I was going into third gear and it was going sideways. And it is daunting for the driver. People look at drag racing and think, oh, it doesn't look very interesting, but I can assure you when you're in the car that weighs 980 kilos, has got 980 horsepower, it's quite exhilarating. It was as close to the bike as I could possibly get, really.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Conrad Bradley, or Armchair Tuner from Instagram, owner of a one-of-a-kind Evo, which is interestingly powered by a Nissan VR38. It's still four-wheel drive, and of course, it's punching out over 1,000 horsepower. I actually bumped into Armchair Tuner as an Instagram profile probably a few years ago, and obviously it piqued my interest given that I am a Mitsubishi guy at heart, and of course I hadn't seen anyone shoehorn a VR38 into the engine bay of an Evo. Thought it was probably time that we caught up with Conrad and actually talked about his backstory and find out how he came to ditch the 4G63, which we all know is no slouch, and decide to go down the route of the VR38. Conrad's actually got a really interesting backstory in that he's not directly hands-on in the automotive industry so much, although he did partner in a tuning shop for a period of time, so he knows the ins and outs of the process. However, he's really leveraging off the skills of others to build this car, but it is still his vision that he's seen through to completion. Now, probably doesn't take a rocket scientist to figure out that putting a VR38 into a Mitsubishi Evo is no small feat. So we talk through the challenges that this created and how he went about still maintaining four-wheel drive, how he's actually improved on the R32 and R33 GT-R transfer case that he's used, backing his Hollinger sequential gearbox to improve the four-wheel drive torque split to the front axle and improve traction. Not only is Conrad a Mitsubishi Evo guy, he's also got a passion for Toyota AE86s, which is another car that's near and dear to my heart. And we talk about his earlier project build, which was a track-orientated AE86 powered by a 250 horsepower 3S GE. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes, and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, Conrad, welcome to the podcast. Thanks for joining us today. And as always, let's find out about your background and how you formed an interest in cars.
Yeah, thanks for having me, Andre. Basically, I always had an interest in cars from being a youngster. Cars and motorcycles, anything with an engine, really. My background is commissioning in oil and gas and nuclear. A lot of process control stuff, so process flow, temperature control, that type of stuff. So I quite lean towards a lot of the tuning side of things in the car industry and stuff. I've had a few cars over the years, different projects. generally like to do the builds, shall we say, and get them to the end product.
Just talking about your job there, which sounded quite interesting, but you kind of only just briefly brushed over that, quite removed from the automotive industry itself, though.
Yeah, so it was. However, it was around 2004 I got the opportunity to partner up with a chap for a tuning garage in the UK, which piqued my interest, shall we say. Gave me an opportunity to get more hands-on rather than just being on the outside. Unfortunately, it didn't work out. We had a dyno, dynamics dyno, etc.
So was this sort of a partnership where your partner was the one hands on the ground running the tuning shop and you were sort of more an investor? Is that how it worked, or were you hands on in the shop as well? It just sounds like you had a pretty full-time job at that point.
Yeah, that's correct. I was full-time in my normal job. Quite often worked overseas, so I was away a lot of the time. My partner used to run the business. Yeah, you were correct. In terms of investing, I put the money up, and it gave me an inside, if you like, into getting to know more about the tuning side and things, and the dynos and what products work, what products don't work. So it was an interesting thing for me.
All right, let's just back up a moment, because you've sort of given us a little bit of a hint about your day job. Before we get more involved in that and then obviously the automotive side of things, can you just reverse up a bit and maybe give us a bit of an understanding of what your education looked like and any formal qualifications you had? I mean, I can't imagine anyone sort of just moves into that oil, gas and even nuclear field without some qualifications up their sleeve.
I guess a lot of it came from experience, Andre. I did a normal school education, GCSEs as they are in the UK, and then I moved into electrical and electronics. We have something called an ONC, HNC in the UK, as well as an apprenticeship. The apprenticeship covered a lot of different things: mechanical, electrical, electronics, that type of stuff. So that's where that came from.
Is that where you've sort of got that crossover interest in the electronics and tuning side with the automotive field?
Yeah, it came from the back of my apprenticeship, really. I was introduced to PLCs, programmable logic controllers, for people that don't really know. And they're basically, PLCs are what control the automate industry, whether it's processors, machinery, and it's all very similar type thing to the ECUs in cars. It's inputs, outputs, analogs, that type of stuff. And I found it really interesting getting into the PLCs, and that led me into various fields. Working for the likes of Coca-Cola and big blue chip companies like that. Fault finding, coding new factories, working for Guinness, doing new breweries. And then in 2005 it migrated into the oil industry, which was oil and gas platforms, oil rigs, FPSOs, which are the floating versions of oil rigs, for those that don't know. And I ended up doing the safety shutdown systems. I ended up doing the process control automation, gas compressors, 400 horsepower, 400 bar gas compressors.
I can only imagine in this sort of industry, you sort of have a lot of people's lives in your hands, I imagine, in terms of if something goes wrong, it's not going to be a small problem, is it?
Absolutely. It's very much safety first, and it has an effect on your personality because you have to become almost OCD with the level of detail on shutdown systems in oil and gas and nuclear facilities is immense. It has to shut down in specific sequences, specific times, and I was responsible sometimes for writing that logic, but certainly for testing that logic multiple times and getting it signed off before you get approval to operate with the regulation bodies and stuff.
Yeah. And just if I've read between the lines correctly, this is all sort of stemmed from your education followed by an apprenticeship, but it doesn't sound here like you've gone down the path of conventional electrical engineering or mechanical engineering degree. Is that correct?
Yeah, no degrees. My age, when I was doing my apprenticeship, it wasn't really a thing in the UK. I'm talking 1980s, late 1980s when I served my apprenticeship.
I think it's important, the range of guests we have on the podcast, though, and particularly those in technical jobs, quite often there is that background of the mechanical engineering degree, but just as importantly, you're proof that there are massive opportunities out there across all industries that don't necessarily actually require or demand a degree. So I think that's quite refreshing to hear.
Yeah, absolutely. It's about finding something that you like and applying yourself. Yeah. If you apply yourself and you become good at something, you can, the world's your oyster. I've met a lot of people along the way that have had degrees, and it doesn't always work out because they haven't got the practical side of it.
Yes, I think we've talked about this in the past on the podcast as well. I think there is definitely a disconnect sometimes between book smart and the ability to get through courses and get a degree, but that doesn't necessarily build up the practical application of those skills, and they can be quite dramatically different. So the other aspect with degrees, having gone through one myself and sort of often looking back and thinking, well, how much of that Bachelor of Technology do I use on the day-to-day? And not a lot on face value, but then when you dig a little deeper, I think probably there is a fair bit that comes into what I've done over the years since leaving university that maybe I sort of overlook. I think what I look at now as an employer, though, a degree in a lot of fields is really just saying to the employer, hey, I know how to learn, which is an important skill. And why I say that is quite often with, other than some very specific degrees, let's say doctor or maybe a lawyer, outside of those areas, you're learning broad skills, not necessarily sort of pinpoint accurate skills for a specific job. And then when you get into a job, then you learn what you need to add to your degree knowledge. So I think we digress a little bit, but I just wanted to talk about the relevance of degrees as we go forward. I've got 2 kids, and if they want to go to university, I'm going to back them, but if they are not showing a lot of interest in university, then I certainly would not be pushing them towards that direction, because I think you can be equally successful with or without a degree. Now, just to bring us up to speed with where you're at today, you're still in the same sort of area of your vocation?
I've moved into a different industry now, so I'm in a nuclear industry at the moment, so doing projects on that. That's probably about as much as I can tell you.
Fair enough. I think when people use the term nuclear, and interestingly, you're now the second guest that I've had on this podcast that works or has worked in this industry, which I find actually quite an interesting statistic. But I think we all instantly go to sort of scenes from Homer Simpson destroying the nuclear power plant in The Simpsons. But what's the reality? Can you talk about anything with that industry, or is it all a little bit secret squirrel?
It's very secret squirrel. But however, there is industry. Previous to the one I'm in at the moment, I was still in nuclear, but it was a different project, and it was more around waste. So there is different trees, branches, if you like, off the tree. Some's waste, some's power generation, some's for other things. Unfortunately, I'm in the other things section. So
sure. Oh, we'll park that and leave it. It's not specifically relevant to our conversation today, so we won't continue pressing and maybe come up against some NDAs that will get awkward. So let's move back to your partnership with this tuning shop. So prior to starting this, obviously you've got this passion for cars. The crossover, I guess, between your day job and then your interest in electronics and tuning. So how did it come to be that you ended up in this partnership owning a tuning shop, albeit maybe hands off a little bit?
So I used to race motorcycles. So we digress a little bit, but the shop that used to look after my race bikes, it was just club level racing on Ducatis, that type of thing. The shop that looks after them, a chap used to come in who had a Honda Civic at the time, and it was a turbocharged Honda Civic, and he was trying to fit a new ECU to it, and I just ended up getting involved because it was an interest to me, and I was listening and learning, and that's how it ended up. And I ended up finishing a job, basically, that I was working on at the time for Guinness, and the opportunity came up. We actually discussed about setting a business up, getting a rolling road, and set terms and conditions out, etc. And that's where it progressed from there. It was very quick coming together, really. Contacted Dyno Dynamics. We found a place to house it. We went to SEMA, spoke to a lot of people at SEMA. So, and it was really good. We had a few issues along the way, with buildings and people around buildings and having to move. And
I've found from my own experience that running a dyno shop comes with a lot of frustrations around noise, because obviously dynos create noise, and it's difficult unless you have incredibly deep pockets to build a dyno cell that is truly silent on the outside of the building. So that's kind of always a frustration. I mean, obviously we don't want to piss off neighbouring businesses, and I ended up having a few visits from our local council, and the interesting thing was we actually sort of fell into this awkward loophole, which meant the council didn't really know how to deal with us, because I don't quote me here, things might have changed, this was probably 15 to 20 years ago, but there was a noise limit that the council enforced. But interestingly, that noise limit was actually averaged over something like a 10 or a 15-minute period. And of course, anyone who's dyno tuned or even seen a dyno in action, I mean, you'll do a ramp run, which will be massively over the noise limit for 8 to 10 seconds. But then generally, you sort of come back down to idle and assess what's happened on the dyno, make the appropriate changes before you perform another run, and that might take 3 to 5 minutes or something of that nature. So the average noise was actually well under the limit, but with periods where we were way over it. So it sort of fell into this weird no man's land. But at the end of the day as well, it weighs on your mind when you've got angry neighbours sort of knocking on your door, or residents around the area. So you do have to kind of do your absolute best to actually keep everyone happy. Otherwise, legislation aside, it's not going to end too well for you. So is that sort of similar issues to what you were seeing?
Absolutely, yeah. It was the first building. The neighbours just didn't want us there. There was neighbours across the road. There was neighbours either side of the unit. They didn't like the noise. There was a second element to it, is they didn't like people arriving and leaving with the cars as well. As much as you try and control the noise in your building, you cannot control the people that arrive and leave.
Yep, that's definitely a tricky one.
So the council got involved, as you mentioned, and we ended up having to move onto more of an industrial state where the neighbours are not too close.
I think picking your battles is probably key here, and being in a true industrial area where noise is expected rather than residential. Obviously, you're just going to have a much easier time of it anyway. Interestingly, one of the things that I kind of learned early on when setting up a tuning shop, and I think it's something that almost every budding tuning shop owner I've talked to over the years has completely missed, is they look at the cost of the dyno, and that's the sort of entry ticket price for a tuning shop. And a modern four-wheel drive dyno, let's say we're talking probably circa 100, maybe 150,000 USD. Obviously, there's a range of prices. Maybe you're buying secondhand, but in that kind of vicinity, I would probably argue that you need to be prepared to spend at least that again on building a room to actually house your dyno. And it's not just about trying to keep this noise down. It's about getting the airflow through the dyno cell, extraction of the exhaust gases to look after your health. And looking back, I didn't do a great job of this early on in my career. And then just as importantly, generally most tuning shops are going to have mechanics working in the workshop, prepping cars, fitting parts, etc. And you've got to think of health and safety for your staff as well, making sure that they're not sort of having to wear air defenders all day long and sucking in exhaust fumes. So those are the things that really sort of ramp up the costs of setting up a fresh tuning shop. So anyway, getting back to yours, continue the story.
Yeah, so we ended up moving. We moved to a slightly smaller unit on an industrial estate. That, again, came with its own problems. Fortunately, the neighbours next door to the unit we had one of these lorries that make concrete. Then when it mixes on board, so they used to fill this large lorry up every evening with water. And then we came in one morning and the unit was about 12-inch deep in water, including the dyno. So that caused us a few issues with the electronics in the dyno and the ramps and other things, plus all the sand that was always around everywhere, which, as you know, sand and engines do not go together. So trying to keep the place clean was difficult. It was later that year, the business just wasn't working for myself. So I had a discussion with my partner and he decided to buy me out. Which was fine with me, and he purchased the dyno, and we came to, we're still friends now. But yeah, it was good, and he carried on.
I think it's safe to say that the majority of business partnerships don't work out. So it is rare when you find one that does work. And I mean, even if it doesn't work out and you can walk away and still be friends, I'd probably call that a success anyway. Now, obviously, for you, this is a sideline gig. What were your takeaways, both positive and negative, about the experience?
I certainly, the LFE, the learning from experience, in the industry I'm in, it's very much a time versus cost scenario. If I have a guy, shall we say, he does 40 hours, he costs X amount per hour, and we apply an efficiency factor to it. What I learnt in the tuning industry there was nothing seems to go to plan. A 1 hour job, if you're taking a manifold off, for example, a 1 hour job, you end up snapping a stud in the head. And
yeah, I mean, there's the old saying that every 30-minute job is only one stripped bolt away from being a 4-hour ordeal. And the other one that I quite liked as a sign, and it says, "We do this not because it is easy, but because we thought it would be easy."
Yeah.
And I still, 20 plus years in the industry later, find myself falling into that exact same trap. Like, yeah, no, we'll do this little job. This is fine. This will be easy. And then you're like, an hour later, skin knuckles, grease everywhere. And you're like, yeah, no, this is definitely a job that I should have got Brandon to do.
Yeah, and when you've priced it, it's very difficult to go back to the customer.
I think the other part of performance automotive, and I battled with this internally for the 13 years that I owned and ran my workshop, it's a difficult way of making a living, because you look at the usual franchise dealership model, and they're working on a very limited range of vehicles which they know inside and out. And they've got techs that are trained on those vehicles, and let's say we've got a Subaru comes in for a cam job, and I don't know, cam belt job, maybe that's got a book time of 4 hours or whatever it may be. The good techs can probably do that, punch that job out in 45 minutes. So the customer's getting charged 4 hours, so straight away the dealership is up on time. The employee's not getting paid 4 hours, they get paid what they worked. Then they've got the markup on all the parts. So straight away, on a good week in a franchise dealership, you're charging out 40 hours for you're paying your staff, I should say, 40 hours. And I mean, you might be on a bad week charging out 45 or 50 of their hours. I mean, on a good week, it might be 60 plus. So you've got that net bonus, whereas I kind of found in the performance automotive world, at least until I cottoned on to a few tricks, that you're almost the polar opposite. It's very difficult to quote work unless it's repetitive work that you've done over and over again. And if I looked at your Evo, which obviously we're going to jump into shortly, I mean, there's no way that I could sit down and give a dollar accurate price start to finish of that job. There's just too many unknowns as you get into it. So, traditionally I'd find we'd work 10 hours on a job, and I'd look at the bill at the end of it and sort of go, well, shit, I can't justify that. That's just out the gate. And all of a sudden, instead of, you're paying your staff member 10 hours and you're actually charging the customer 7. And these days, most customers are probably able to source hard parts like turbos and wastegates and blow-off valves and computers kind of at or very similar to the price that the shops can anyway. So it's difficult unless you get into that repetitive work. Now, for those who are sort of thinking I'm kind of making the performance automotive industry sound like a very bad way of making a living, well, that's not all the case. It's just, like I said, learning the tricks. And like I've mentioned on this podcast before, where we sort of found our stride was when we started specialising in a particular make and model. For us, it was the Australian domestic market Holden Commodore. We were dealing with customers that had just dropped, 100K on a new vehicle. So they were in a different sort of demographic to the young guys and girls with, $8,000 Honda Civics. And we had a formula of parts. We knew exactly what the parts cost. We could fit them quickly, and you could tell the customer within probably 1 or 2 horsepower what it was going to make. We were doing, maybe between 2 and 5 of these in a week. So often it would take longer to bolt the car on the dyno and off the dyno than it did to actually perform the tune. So that was where we were getting the economies of scale. But I digress. I just wanted to sort of get my experience into that.
No, absolutely. You hit the nail on the head. It becomes bread and butter, doesn't it? The stuff that you do day in, day out, and you know what parts work, what parts not to use. The tunes goes in, and like you said, it might just need a little tweak, and that's out the door, and you've got some revenue coming in.
The flip side of that for me is that doesn't spin my wheels. That's boring work. When I do it the first time and I'm developing the tune for the combination of parts, yep, cool. That's where I enjoy the tuning work. But just rinse and repeat tuning, I don't enjoy. What I really was passionate and am still passionate about was the big project builds. And as I've kind of alluded to, those are the ones where it's difficult to really make good money unless you've probably got one customer in 10,000 that's actually got the correct financial resources to do the job properly, start to finish, isn't going to question every bill that you send out. And that's where you can kind of really do a quality job, really get your teeth stuck into it, learn some things along the way, and have an enjoyable experience. So I kind of found I had to balance the two, have the cookie cutter rinse and repeat work that was great for profitability, and then the other jobs which we really enjoyed building, but also just as importantly, it's those big jobs, those big builds that we don't really maybe make a heap of money on, that are the ones that are going to set headlines, for times on the drag strip or lap times or whatever it may be.
Bring people to the shop.
Yeah, and that's good for marketing. So I think, a bit of a mix of the two is important.
Yeah, and I think where we went wrong is we weren't getting that bread and butter stuff through the door to keep the business afloat to a point where it was making money. That was the issue. We had a lot of big builds on, and you end up with a lot of shells outside and a lot of engines on stands, and you're just not getting through it. That's a problem. So
yeah, I think the lead time on the bigger builds as well can really be problematic for cash flow. I mean, obviously you can kind of ask for progress payments as you go through these builds, but I mean, some of these builds are 12 months, 24 months, and obviously substantially longer. So yeah, there's the payday can be quite a long way down the road. All right, I think let's start talking about some of the vehicles you've been personally interested in. You've obviously mentioned you've got a background in racing motorcycles. Where was the transition to cars? Why'd you go that route?
So it was 2005 when I retired from motorcycling. I'd done okay. I wasn't in the top 5 all the time. I'd run around, probably top 10. I enjoyed it, but I got to a period of racing the bikes when you're going around a track and you're in 5th or 6th, and you're actually asking yourself why you're going around, why you're doing it. It's time to call it a day. And I went through a period where I kept losing the front end on the bike and ended up doing the washing machine sky gravel grass as you're rolling around, and I thought, I've had enough.
That's always what's put me off motorcycle racing. I kind of like just having a little bit more protection with a race seat, a harness, and most importantly a roll cage around me, and you don't have any of that.
Yeah, it was back in 2005, which was 15, 19 years ago, nearly 20 years ago, isn't it? Time's marching on. I was in my 30s and I just wasn't healing as well as I had done when I was younger. It was taking a lot longer. So I called it a day, and I needed to find something that would replicate that feeling, that thrill. So that's how I started getting into cars, really.
Now, I find it interesting that you've obviously gravitated towards the Japanese domestic market models. But being based in the UK, I would have thought that access to cheap Euros would have been pretty prevalent. What is it about the JDM vehicles that really attracted you?
I guess I liked what you got as a package, from the JDM stuff. they just offered, didn't they? If you look at the Hondas, you look at the Evos, you look at the Subarus. I'd always liked lots of Subarus first. I struggle with the reliability a little bit, the Subarus.
Doesn't everyone?
Yeah, just the big ends are really narrow, aren't they? So I had a few problems there. So I gravitated away a little bit from the Subarus, but you were looking at Honda Civics and what they were doing, and my colleague had the Honda Civic with a turbo on a B16.
It's a great combination.
Yeah, it was incredible, and then the Evos came along, and they just offered everything that you wanted, as a base to start, and the tunability of the JDM stuff is fantastic. Back in the early 2000s, the tunability of the Euro stuff just wasn't there really, unless you wanted to slam it and put massive camber on and airbags. It was
a different style of tuning. I use air quotes around tuning there.
Yeah, it was never my thing. That it's.
I mean, coming from New Zealand, we have very easy access to all of the JDM models with essentially no local manufacturing base for vehicles. We had no import duties or tariffs, etc. So a fairly free flow of JDM imports straight from Japan. On the other hand, we have a relatively limited number of European cars here. I mean, yes, they do exist, but I kind of guess that probably it's almost the polar opposite of the UK in the JDM versus European numbers. You mentioned the lack of tunability in the European car market. I'd sort of almost argue that not too much has changed there. We've got access now with some of the aftermarket reflashing tools, like HP tuners obviously now offer relatively wide support for a number of Europeans. But back when I was running my tuning shop, that absolutely wasn't the case. And the ones who were doing it in the UK, or through Europe, I should say, not just the UK, and making really good money out of it were inevitably using the likes of WinOLS and actually reading the ECU contents and then creating their own definitions. And then obviously they wanted to keep that completely close to their chest. So it was a very different tuning market. Is that kind of what your experience was as well, being within the European market?
Yeah, absolutely. It was very much the same. A lot of the early European stuff, if you look at BMWs and Renaults and stuff, maybe 5 GT turbos and stuff were early doors, and the tuning for them was like, bleeding off the wastegate pressure, etc. It was and adjusting the fueling with a fueling module. It was all like piggyback stuff. The European, like BMW and stuff, they were naturally aspirated, and Winolls or Dim Sport used to do it from Italy. Used to be able to get their stuff, read it, get a bin file for the definitions and stuff. But you were getting, 5 to 10 horsepower if you were lucky.
It's hard to get excited with the majority of naturally aspirated engines because there simply just isn't that much power left on the table in a lot of instances. Whereas obviously you start with almost any base model turbocharged engine, and not always, but in 90+% of circumstances, increase the boost by 2 to 4 psi, maybe 5 psi. Probably you're still going to be well within the safety limits of the turbocharger and the engine internal components. Add a caveat, obviously not always, but that could net you 20 to maybe 60 or 70 plus horsepower gain. So relatively easy pickings with just a tune, and then obviously start adding hardware modifications on top of that, and the sky literally can be the limit. In terms of the European models that I guess were popular for modification around the time you were starting looking at these Subarus and Evos and turbocharged Honda Civics, what was comparable?
There was probably around 2004, 2005, you're probably looking at Renault Clios type of stuff, the Citroen Saxo VTSs, which are 16 valves. They were small like cars, but they had some go in them from the factory, the Citroen Saxos and the Renault Clios, and they're still today really good track cars, very popular in the UK. Other than that, you were struggling, What made it even better for the JDM stuff was when Ecitech appeared. It made life so much easier for tuning the JDM cars, the Subarus and the Evos. It just opened up a whole world of, I can bolt all this on and I can get a tuning file relatively easy, or from a supplier, if you like. Go to a supplier with Ecutech.
Sure. I guess over in New Zealand, the go-to option for tuning on both the Subaru and the Evo platform was, and probably still is, ECU Flash, just given that it is, for all intents and purposes, free. It's open source software. There's a community supporting it with a lot of forums. Was that a tuning option that was prevalent in the UK as well?
It did appear, and quite a few. You had the professional shops that would generally have Ecutech, but you would get the, how to put it without offending anyone, you get the people that were doing it on the side, if you like.
Yeah.
They'd tend to get the open source stuff and the ECU Flash.
For those who maybe aren't kind of picking up the pieces of what we're talking about here, we're talking about techniques of reflashing, or in other words, recalibrating the factory ECU. So you're basically working with all of the hardware that the car's already got. Benefit with doing this is that you don't have to buy an expensive aftermarket ECU. The problem, though, is that when we read all of the information out of the stock ECU, it's a raw binary file. And if we look at this, it's like staring into the matrix. It's just numbers that, as a tuner, well, at least it makes no sense to me. So what we need as tuners is what's referred to as a definition file. Think of this as a roadmap. It essentially says, well, the fuel map is at this address and it's this size, and then the axes are here and here, and then just as importantly, these are the scaling factors that turn our raw values into actual numbers that make sense, and repeating this process over for all of the other parameters and tables that make up an ECU. So when we deal with a professional aftermarket reflashing supplier like Ecutech, like HP Tuners and all the rest, they are developing these definitions, and generally they do an exceptionally good job of it, which means that the definition file we can trust. It's going to be complete, or at least relatively complete. It's going to give us access to all the maps that we need to actually tune the vehicle. The flip side of this is, in the open source community, it's just unpaid enthusiasts that are kind of doing that heavy lifting of making these definitions, and they're not all created equal. Some are exceptional, and other times, you might have no access to a wastegate map, or worse still, you might have access to an ignition timing table, but it's actually not the correct ignition timing table. So these are the problems we face when we're using open source software, but we weigh this up with the fact that it is essentially free versus Ecutech, which is quite an expensive process and not really a suitable option unless you're a tuning shop. Do you sort of agree with all of that?
Yeah, absolutely. To get the tuning software like HP Tuners or Ecutech, you're having to buy the package, and then you're having to buy the add-ons, which are, for example, it's an add-on for a Subaru, it's an add-on to be able to do Mitsubishi Evo VIII, VIII and IX, etc. And it becomes very expensive.
Yeah. Fine if you're doing it commercially and you can recover those costs because you might be tuning sort of 10 or 20 of these vehicles every month. So yeah, that obviously makes sense, but definitely not to the individual.
But as a professional shop, like you said, it's important that when we think we're modifying the fuel table, we are modifying the fuel table. When they're putting these out, they've already been tested and proven,
I think the other thing I should have added in there when we're talking about the differences between open source and commercial reflashing solutions is if I have an issue and I'm tuning using Ecutech, generally I've got a line directly to Ecutech. I can get support on that particular product, and they're going to be able to generally help me through the issue that I'm having. In the open source community, if I'm tuning using ECU Flash and something isn't quite working right, I'm absolutely on my own, short of posting a question in a forum, and then you generally got to sort through fact and fiction when you're getting replies as well. So it's I would say, suitable for the more experienced and advanced tuner. Certainly jumping into the open source world, if you are absolutely fresh to tuning, I mean, hey, it might go exceptionally well, but when you do strike problems, it can be a lot more difficult to extract yourself from that situation and get the solution. Now, again, I think we've kind of gone off on a tangent, which is absolutely fine, but coming back to the vehicles, you're obviously an Evo guy at this point. You've mentioned the Subaru and the reliability problems, which I definitely don't disagree with. Was it sort of a coin toss between the Subaru and Mitsubishi platforms when you were looking at options? And is the reliability sort of what drove you towards the Mitsubishi platform?
To be fair, I found with the Subaru, if I left it at a certain point, it was pretty good. It was a good all-rounder, and they've got character. The engine's certainly got character.
Oh, definitely.
But then I acquired my first Mitsubishi Evo VIII in around 2005, I think it was, and it was just great out of the box. It was a Japanese import by a private importer from the UK, and it just ticked all the boxes, Andre. It just did everything you wanted, no issues. It was reliable. It was really good.
I think just talking about the Subaru for a moment, and I mean, they do get a pretty bad reputation, and not all of that is necessarily warranted, I think. You mentioned the narrow Conrad or big end bearings, and that's definitely an issue. It's kind of driven by that compact nature of the Boxer 4-cylinder. Obviously, this sort of leads them to being known for connecting rod bearing failures. That's probably one of the more common failure modes that we see in the EJ series of engine. And then, of course, following that, there's the glass gearbox that the 5-speed in the GC8 had. And that was a terrible gearbox. Once they went to the 6-speed, that's actually a pretty good thing. Where I'm going with this is I think a lot of the issue with the Subaru engine reliability actually comes down to poor tuning. And this actually starts in the factory. I don't know what it's like in the UK or other parts of the world where Subarus were delivered factory new, but we would tune a number of turbocharged Subarus of all sorts of different varieties that were 100% stock standard. Some of them, 1,000 miles off the showroom floor, and on good quality pump gas in New Zealand. I put them on the dyno, and they every time would be suffering from some level of detonation. And the problem is that detonation puts a shock load into the big end bearing. So if you allow that to continue running with knock occurring over time, and obviously as the specific power level increases, the time decreases, you are going to end up with a bearing failure. It's almost inevitable. So I think where I'm going with this is the tuning is so important. And if we actually tune the engine properly, so we're running correct air fuel ratios and we stay away from knock, a lot of the common failure modes with the EJ series engine just sort of go away. Now, of course, crank these things to 1,000 plus horsepower and then we get a whole new set of problems. And I'm not saying it's impossible to do this, but if I look at a 4G63 and an EJ20, EJ25, I know which platform I would pick if a reliable again in air quotes, 1,000 horsepower was my aim. So I just wanted to add that in there so that people don't think that we're bashing on the Subaru platform. Just like every platform, it has its strengths and its weaknesses, and we need to understand those. All right. This Evo 7, what was the aim with it, and where did you sort of end up going with it?
Unfortunately, I only had it about 6 months, and a driver hit me head on when I was on my way home from work. Broke every window in the car, destroyed the car, broke my foot, and put me in plaster, and so that was the end of that.
Okay.
I was absolutely gutted because it was immaculate. It was a real nice example. So I spent 11 months in plaster, backwards and forwards, and then I moved on. I left it a while before I bought another one.
Right. And what was the next one?
So then I sourced an AE86. Just for something different. It was another project, really.
Yeah, well, you couldn't get more different, really, could you? Lightweight, rear-wheel drive, naturally aspirated versus heavy four-wheel drive turbocharged.
Yeah, it was good.
And also completely analog with no technology.
Yeah, and it was more of a driver's car. It was great, It was good fun. It was very difficult trying to keep the back end in line because the one I purchased had a Japanese diff in the rear, which I think was tightened up very much for drifting. So on the road, it was a little bit hairy initially.
What was the combination? Give us sort of a high level quick overview of what the build spec of that car was.
So originally, it was just I looked at 12 before I purchased this one, but a lot of them that were being brought in were rotten.
Unfortunately, that's one thing that Toyotas of the 80s and even the 90s did exceptionally well is rust. Yeah.
Yeah. Eventually I found one. It was a chap who was selling some other ones, and I saw this one in the corner, and it caught my eye. And I was like, what about that one? And he says, no, that's mine. I says, no, that's the one I want to have a look at over there. And it was clean as a whistle underneath, low mileage. I think it was like 50,000 miles. I said, no, I don't want the other ones. I'd looked at the other ones and they were not good. He had about 4 or 5. So anyway, I talked him into it and he let me have it in the end. The original plan was, which most of my projects end up like, the original plan was to put a roll cage in it and go on track day and have fun.
Yeah.
Unfortunately, the project just grew arms and legs.
Yeah, hard to believe how that always seems to happen.
Yeah, so the little 1.6 got pulled out before it went down to the people for the cage. Everything else got stripped out of it. My son was in the back helping strip it out at the time. And then it just went down to the fabricators and we ended up putting a cage in it, which was tied in everywhere to all the main strut suspension points.
What sort of time frame is this? When are we talking? What year?
This will be 2005 when that started.
Yeah, okay. So probably 2005, maybe the AE86, not quite as valuable as they've become, and they continued to increase in value. I'm just interested, was there any sort of difficult decisions around taking a JDM hero car like the AE86, which by the sounds of it was in immaculate condition and relatively stock, and then pulling it apart and welding a roll cage into it?
There wasn't from my point of view. On some of the forums I was frequenting, there was a few of the purists that were not happy. But I think, with your own projects, you've got to put your own stamp on it. You've got to do your own thing, If the end value is not of interest to you, then you do your own thing. I think initially I had an S2000 engine and gearbox for it because, it was one of the most powerful naturally aspirated factory engines with a 9,200 RPM, and it seemed like an ideal candidate.
Hard to argue with the logic.
Amount of grief I was getting online from the on the forums. So I don't know why I let them sway me, but I started to have a look around at other options, and I thought, well, have Toyota produced anything? So I had a look around, and sure enough, I found the Beams engine, the 3SGE blacktop Beams engine, which were not quite as powerful as the S2000, but they were 210 horsepower from the factory.
I mean, it's hard to find a naturally aspirated 4-cylinder from almost any manufacturer outside of sport bikes that stacks up to a Honda F20, or obviously K20 is very, very similar, and the K20 has kind of become the gold standard. So I do struggle with engine swaps where you're going to a different manufacturer of engine to chassis, and I say that knowing full well that we have a Nissan SR20 VE engine in our Toyota 86, but that was more a case of necessity if we wanted to go racing, rather than waking up one day and thinking, hey, you know what, this is going to be the best combination in the world. If I had my time again, it probably actually still wouldn't be a Toyota engine in that chassis though, so maybe not the best example, but yeah, I kind of do get that. It's interesting how vocal forums are about what someone should be doing with their own car, though. I think to a degree, you kind of have to bury that noise and do what makes you happy. It's your car. Yeah,
so I did look at it, and at the end of the day, I did a lot of research on what was available from Japan, because they were in the old Tezza. The old Tezza in the UK was called the IS200, the Lexus IS200. But it didn't come with that 4-pot. It came with a 6-pot Lexus engine. So I ended up having to source it from Japan. While I was doing that, I was talking with Toda and Tomai, and to see, these guys had raced them around circuits in Japan, so they knew what was possible to get out of them. So I ended up purchasing most of the components for the engine, which was rods, piston, high compression pistons, relative to UK fuel, not crazy. I think it was probably 11.5, 12 to 1 back then.
It's always the balancing act when you're building a naturally aspirated engine. Obviously, you've got the flexibility with a turbocharged engine that the compression itself is not really the key factor in terms of outright performance. It's boost pressure clearly, and we can have a combination where we run a low boost pressure on pump fuel and maybe have separate mapping if you want to run E85 or race fuel and really lean on it, and we can see dramatic differences in power. Not quite that easy with a naturally aspirated engine. We do really need to choose a compression ratio that's going to work with the lowest grade of fuel that we want to run. Otherwise, the tuning becomes really problematic.
Yeah, absolutely. So that's why we went with, I think they were probably 12-1 Toda pistons, and then I selected their cams that they'd used without, too much overlap and etc., which would have some lower down power on the road, if you like. Nothing worse than a car is that's flat below 4,000 RPM as a road car. It's it's terrible, and there seems to be, the whole industry seems to be crazy figures in it. What people don't realise, without the control element, if like a naturally aspirated engine, if it comes on cam at 4,000 and it's vertical, the power and torque, you just break traction anyway. So you're not moving forward. It becomes almost undrivable,
I think forums and magazine articles really have a lot to answer for here. I saw this just time and time again with customers through my shop. They'd come in, have just read an article in the latest performance car magazine, and now they want 800 horsepower from their Evo. And if you're building a drag car or maybe a high-end time attack car, well, yeah, obviously that sort of power kind of is a requirement at some level. The reality, though, for a street car is that 800 horsepower, it's getting better and better as turbo technology improves, but basically that 800 horsepower is probably going to come with a power band that doesn't start below 5,000. And you're going to be slower on the street than a car making an honest 500 horsepower with a power band that's sort of 3,500 through to 8,000. So I think definitely the power number's great for internet bragging rights, but in reality, you have to choose something that's suitable to the way you're going to use the car. Case in point, we've got an Evo 9 as one of our shop cars, development cars. At the moment, the thing's essentially stock standard, but we've got a 4G63 2.2 Evo 9 MyVex stroker engines just sitting on the shelf waiting for a time where we can fit it. And I built that engine with the intention of being able to support an honest 800 horsepower. It's in one of our practical engine building worked examples. And the reality is I will probably actually detune that and choose a turbocharger that'll probably be more around the 600 horsepower mark maximum for that exact reason. It's not a race car. It's not a track car. It is a road car. And it'll be faster and it'll be much more enjoyable with less power.
Absolutely. And as a road car, you want the biggest area under the curve that you can get.
Yeah, exactly. Yeah.
You don't want a 3,000 horsepower peak, if you like, a 3,000 RPM peak, sorry, You want it to go from 2,000 RPM to your 8,000 limit and have as much as you can, the flattest torque curve you can get, and it'd be lovely to drive, When we're younger, like you said, everybody's chasing the horsepower goals, but it's physics. It all ends up at one end of the RPM scale. Yeah.
Yeah.
And they're just horrible to drive.
Case in point, I mean, my Evo drag car in its final iteration, it was making 1,166 horsepower at the wheels, 54 psi of boost, and that revved to 10,500 RPM, maybe 11,000 on a good day. But if you overlaid a power curve on our dyno with a stock Evo 3, my one didn't actually come on boost until 7,000 RPM, and the stock Evo rev limit 7.5. So there's this tiny sort of 400 RPM of overlap where my Evo was doing a better job, and everything else below that was just dog shit. So obviously on the drag strip, we launched the car at 7,000 RPM, and it never drops below that for the rest of the run. But just case in point, I mean, if we were ever to be able to drive that thing on the road, a stock Evo would have absolutely decimated it. So it's a case of choosing something that's suitable for what you're trying to achieve. But let's get back to the AE86. So am I safe to assume sort of individual throttle bodies on this in place of the stock plenum?
Yeah, so I made contact with a chap in Australia who specialised in Beams engines, and he supplied me one of his kit individual throttle bodies with the trumpets specified to where we wanted the power to be, and a carbon style airbox to go around them. So Last thing I wanted was some road stones going down the throttle bodies.
Yeah, the open sort of inlet trumpets look great, but not very practical if you want reliability.
Yeah, on the street, again, it's not really a practical option. So a chap called Pete Whitfield built the engine. He used to work for McLaren in the UK, assembling engines. So he was a friend of mine. So he put the engine together. Worked really well. It went from, it made on the dyno, we used a Motec M800 custom loom, and it made 205 horsepower at the wheels. It doesn't sound a lot in today's, figures, but it was a nice curve.
You also got to understand you're dealing with a car that it's probably sort of under 1,000 kgs. I'm going to guess complete.
Yeah, it was around 860, Andrew. So it was lively. It was certainly lively, and it was rear-wheel drive, so it made it even more lively.
I'm interested, knowing that sort of platform reasonably well, the stock T50 gearbox and the stock rear end probably aren't going to have a really good time at 200 plus wheel horsepower. So the transmission, I'm assuming you went with the 6-speed J160 Altezza box, but what about the rear end?
It was a built 86 diff with an LSD in it. And to be fair, I'd had it cryo-treated. I've had great success with the metal treatments, and both on the 86 and later cars. That's used in the aircraft industry. There's a reason they use all the shot peening and the isotropic, polishing and surface finishing and cryo. It makes a huge difference.
I do remember a bit of a swing and a miss with cryo treatment, but I'd class this as just simply hoping and praying for way more than it was capable of. Back with my Evo, we were probably in the circa 800 horsepower at the wheel mark, and those early Evo 1 to 3 gearboxes are definitely not known for their strength at that sort of power level, and I wasn't quite financially ready to step up to what was the time PPG 4-speed drag dog box. So we tried in vain with the cryo treatment, and suffice to say, it didn't work well for us. But I think when we're already making more than double the factory horsepower and we're running it on a drag strip with sticky tires, probably the result was probably pretty predictable, I would say.
Yeah, I mean, when we talk about one of the other cars later on, I'll give you an example of how well it did, but it certainly did the thing. So apart from the engine internals, it was Motec. There was an AM dash in there. The change really was on the outside. I changed the body shell shape, which I think I ended up getting more grief than anything. But I wanted to run wider wheels on it, and to get them under the arches, which is a UK law, you can't have them open wheel. They've got to be covered. So I looked around for 80s cars for inspiration, and basically, if you looked at the old E30 M3s, Vauxhall Novas, that type of thing, some of the Lancias were the same. So I got the fabricator to make the arches the same, and it actually suited the car really well because it was an 80s car, and the finished product was just, it was lovely. It was fantastic,
I think with those AE86s, unless you're purchasing one of the well-known wide body kits or flares, you're probably not going down that path that people expect. So hence you're going to end up hearing about it.
Yeah, my OCD was a little bit on the steep side for those type of screw-on arches, that were held on with self-tappers. It didn't really wash with me.
No, fair. I totally understand. So what's the car you still own? What are you using it for? Is it sort of actual for competition, or is it track days, or anything in between?
The 86 or?
Yeah, the 86.
No, I don't actually own it anymore, Andre.
Oh, you don't? Sorry, take it back.
No, it's fine. It stayed in storage for a while. It was one of them things. It was supposed to be a track car and a fun car, and I ended up investing so much money in it, and it was immaculate, and I was like, I can't afford to risk this on track,
Yeah.
I was worried. So eventually it went up for sale, and I believe it's now in Europe somewhere. It went to actually an Australian chap who was married to a Lithuanian girl, because he contacted me when he bought it from auction, for the engine specs and some other bits and bats. And he took it to Lithuania or somewhere like that, but he had access to circuits, so he was planning to use it for circuits. potentially racing it. So
always difficult sort of saying goodbye to a car that's had that much time and money and sweat and tears poured into it, but we can't kind of hold on to every single car all of the time either, so natural progression, I guess.
Yeah, absolutely.
So following this back into the Mitsubishi world?
Yeah, so I had a brief, shall we say, a brief encounter. I bought myself an Evo X, which again, for the Evo fraternity, they always classed them as not being a real Evo, didn't they?
Yeah, I kind of feel that way about them as well. I was never really drawn to the Evo X. Nothing bad to say about the 4B11 engine, but it's just such a physically bigger and heavier car than the preceding Evo 9. I mean, interestingly, we did a little bit of development work on the Evo 9 to sort of build up some packages like what I was talking about with the Holden Commodore. I mean, there's nothing groundbreaking. Thousands of companies all around the world had done it all before us, but I distinctly remember we had a colleague friend of ours who bought a low-K Evo 9 New Zealand new vehicle, completely stock standard, and I dynoed that on our dyno pack at the time, and it made 195 kilowatts at the wheels, which I thought was pretty stout for something that was supposedly 206 kilowatts flywheel stock. And we did a bunch of work to that, and exhaust intake, tune, and I think we got it up to about 250 kilowatts, which was a really, really nice package. We did similar a bunch of years later on an Evo X, and I mean, this one was still stock standard, definitely wasn't brand new, Japanese import, and I dynoed that, and it made 185 kilowatts at the wheels, which I was actually really taken aback that it was less than the previous model, plus it was heavier. Granted, by the time we'd basically done the same set of modifications, the 4B11 punched out more power than the 4G63. I mean, all around it is a superior engine. It's more tractable, etc. But is it an Evo? I don't know. That's a debate I probably don't want to sort of get too many people offside with. But definitely a different kettle of fish. Let's leave it at that.
Yeah, it was different, and again, like you said, we talked about the nuances with the Subaru. The Evo X came with its own. It had clutch master cylinder issues, the diff pins had issues, and you had to fix them because it destroyed the diffs if you didn't put different pins in them. And the block itself being the open deck, it wasn't the best. So we put liners in it, we put Darton sleeves in it, 2.2, because you could go bigger bore on it and get it up to 2.2 without stroking it. So it was over square. I called it Project Response because the idea was what we talked about earlier, it was a street car, it was not going on track, and it was to get the widest power band I could get out of it. And bought a little turbo from America, from one of the companies that were making them for the Evo X. And in the end, it made 622 horsepower at 8,500 RPM, but the power band went from 3,000 to 8,000. And on the road, it was just absolutely fantastic because the chassis is great. It is a really good handling chassis, and it was what the Evo X needed. It was pepped up, and it was reliable, and it was really good.
Yeah, sounds like a great combination. I think definitely the Evo X, my relatively limited experience with them in stock form, I haven't really found them overly impressive. But I mean, you could also say that about a bunch of cars that are popular for modification. It's sort of the sum of the parts. Once we actually start extracting the performance out of them that's possible is when they actually really start to shine.
Yeah, absolutely. And I think the 4B11 was like that. It was the head flow alone was far greater. It was a much better head than the earlier 4G63s.
Relatively speaking, the 4G63 as an engine is relatively low tech. I mean, sure, they kind of put lipstick on a pig by adding MyVec in the Evo 9, but it still stands that it's a dated engine design, and technology has just simply moved on.
Yeah, but the 63 was a stout engine. There's no doubt about it. It was, it was very robust.
Well, I think you're starting with a cast iron block and that closed deck style, and now literally everything is alloy in the block for weight saving, which granted, that's a great benefit. And, as you mentioned, the 4B11, there's a lot of these engine designs which are open deck, so the sleeves are not well supported, which means that once we start increasing the cylinder pressure, we start having those sleeves move around and you have head gasket integrity issues, and those are all really expensive to fix. Whereas there's a number of people who are sort of 1,400 plus wheel horsepower on what is still a stock cast iron 4G63 block. But you're not probably going to make that with a 4B11 without dumping a truckload of money into it anyway.
Yeah, and I think we're seeing more and more manufacturers now produce, because it's the casting process as well, the open deck blocks, the aluminium blocks. The manufacturers, I'm pretty sure they don't want people to be tuning them. So, the earlier blocks, they suddenly realised what they give us, 2JZs and 4G63s, and the potential was massive with that closed deck cast iron blocks. So it makes you wonder whether, as part of the cost of producing these newer blocks in alloy and open deck, is it also that, make it difficult for us to tune them?
Yeah, it's an interesting question. It'd be nice to know how much the OEs actually consider the aftermarket when they're designing and building their cars. My guess actually is probably not very much at all, but it is very interesting that we look at a 4G63 and we can produce 4 to 5 times what the factory power was. 2JZ probably significantly more than that. I mean, most of the fast drag 2JZs have now moved to billet, but I mean, I'm pretty confident in saying some of the cast blocks were still up at the 2,500 to 3,000 horsepower mark, which was absolutely insanity.
RB26s as well.
Yeah, well, the RB26, exactly. But I mean, we talk about safety factors for design, and a 1.5 times safety factor or even a 2 times safety factor is pretty conservative. And I mean, these old cast iron blocks are just like out the gate beyond that. So it's interesting that they were so over-engineered, and I mean, I'm for one absolutely thankful of that. I just wanted to take a moment out of our interview with Conrad here and talk about a package that we've put together that's going to be perfect if you want to learn more about some of the tuning aspects that we've talked about so far in this interview. This is our tuning starter package and includes everything that you need to know to go from zero previous knowledge to being able to complete your first tune, irrespective of the ECU and car that you want to tune. This package starts with our EFI Tuning Fundamentals course, which teaches you the core tuning principles and techniques that you'll need to understand. You'll learn how the engine operates, and you'll also learn how the engine responds to both fuel and ignition, and essentially what we're trying to achieve. Next, we move on to our practical tuning course, where you have the choice between our practical standalone course, perfect for those of you wanting to learn how to tune aftermarket standalone ECUs like the Motec M1 that Conrad has in his Evo, or our practical reflash tuning course, which teaches you how to reflash the factory-fitted ECU that came in your car. Again, both of these courses are generic, so it doesn't matter what ECU or car you're tuning, the course is going to be perfect for you. Both of these courses include a simple step-by-step process, so you can break the entire tuning job down into bite-sized steps. This way, each of those individual steps is relatively quick and easy to complete, and in no time, you've got a completely tuned car that's going to be delivering great power, great torque, and most importantly, great reliability. Both of these courses also include a library of worked examples where you can watch the step-by-step process being applied from start to finish on a real tuning job, where we vary both the type of vehicle that we're tuning as well as the ECU that we're tuning on. Next, we include our Understanding Air-Fuel Ratio course, which in my opinion is probably one of the most misunderstood topics in the world of EFI tuning. You'll learn how the air-fuel ratio affects the engine operation as well as tailpipe emissions. We'll give you some safe starting air-fuel ratios for a range of different engines so you can get your engine up and running quickly and safely with absolutely no risk of damage. Most importantly, we'll then show you how to optimize and find the ideal air-fuel ratio for your engine and application. This package also comes with 24 months of gold membership, which gives you access to our private members-only forum. This is the best place to get reliable answers to your specific tuning questions, and you'll get access to our weekly live members webinars. If you can't watch live, you'll also have access to our webinar archive where we've got over 350 hours of existing webinar content. These webinars are live lessons on a wide range of performance automotive topics, and this is an absolute goldmine and one of the fastest ways to expand your knowledge. Normally, this package deal is $417. You can use the coupon code EVO100 and that'll get you $100 off, bringing it down to just $317. You still get the ability to use our payment plan, and this allows you to split that $317 payment down into as many as 8 individual weekly payments. You are still protected with our 60-day no questions asked money back guarantee. So if you purchase and for any reason at all decide it isn't quite right for you, let us know. You'll get a full refund of the purchase price. Let's get back to our interview now. Let's get into drag racing with the Evo platform. So is it after this Evo 10 we actually went back a model and started building something for the drag strip?
No, actually, after the Evo 10, I did an Evo 9 GT. It wasn't a massive build, it was dropping pistons, and it was the first time the FP Black turbo had been produced from America. So it's probably one of the first FP Blacks to come into the UK.
So these are sort of a stock location replacement turbocharger that outwardly looks the same, but force performance, compressor and exhaust wheel with a lot more flow and a lot more power potential.
Yeah, it was tremendous. It did over 600 horsepower on UK fuel as a bolt-on. It was incredible, really. I put the drop-in pistons in and the fuel pumps and stuff to make it work. But again, it was like we talked about. It was a peak number, and it was quite a big wheel in there, so it was boost response was pretty slow.
I haven't had much hands-on experience with the Force Performance product, and obviously they were a staple of the Evo tuning world. That FP Black, as I understand it, was quite laggy, although yes, it would make the top-end numbers. And they had, I'm really stretching my memory now, I think the FP Green was probably their sort of entry-level, a little bit more than stock, but still retaining all the drivability. Does that sound about right?
Yeah, the Green would do probably around 475. We calibrated quite a few in the tuning shop, and then they had a red in between, which was probably around 550. You're correct, the Black was laggy, and it was about peak numbers.
I think this is kind of almost like shopping for camshafts as well. Like if you went onto the Force Performance website and you were, looking at the green, the red, or the black, well, the black has a bigger number, so obviously that's the best. But same with choosing a cam. Obviously, just go down to the bottom of the list and get the biggest, ugliest bump stick that you can and chuck that in because that's going to make the most power. But the reality is, yes, that peak number might be great, but everything else is maybe gonna suck as a result.
Yeah, absolutely. So moving on from that one, that was when I decided let's have a go at drag racing, with an Evo. So I got an Evo 8 rolling shell. So it was on wheels and suspension, basic suspension. We stripped it, put fiberglass doors in it, and then I didn't build it, but I specified and bought all the parts for a high revving long rod 2-litre in a 64 block.
So just for those who aren't up to speed with all of the engine combinations, what is this long rod engine combination? What's that actually mean?
So basically, you've got a stock size rod and on an Evo, I can't remember the numbers, Andrea, sorry, but
156 millimeter. I don't know why, but it just sticks in mind.
Yeah, so maybe a 156 rod, and then the pin in the piston is in the correct location, obviously, so that the pistons don't come out of the top of the block. By going on a longer rod, you end up moving the piston pin up the piston, and what you find is it allows them to rev better.
You're improving the rod to stroke ratio, essentially.
Yeah, you improve the rod to stroke ratio, and you end up with the piston being at the top of the bore slightly longer, and it seems to give some performance gains. So I went with a 64 block, which gives me a slightly bigger piston. So you end up at 2.1 cc, if you like, with a longer rod. And the intention was, being a drag car, was to rev it to around 10,500. So I purchased all the valve train and the springs to be able to cope with that, having spoken with people in America and stuff. The engine was built. It was all super finished crank, etc., shot peened and not the crank, the rods and stuff, take the stressors out.
Just interested, just to come back to that cylinder head, one of the advantages with the 4G63 cylinder head is the roller rocker arrangement. Well, there's pros and cons with that, but in my experience at least, they were a pretty reliable thing, but they also in stock form use a hydraulic lash adjuster or hydraulic lifter. So it's a hydraulic cam profile, and these little lifters sort of pump up to take up the valve lash. And again, those, other than being noisy, if they're not maintained at higher mileage, they do a pretty good job, but can be questionable at the sort of 10,000 plus RPM range. Did you stick with hydraulic, or did you convert to a solid lifter arrangement?
No, we went to a solid lifter arrangement. I didn't want to take the risk. We'd seen what happened on some of the earlier Evo engines that we'd done with the oil pressure and the cavitation, up at 8.5, 9,000. So I wanted to make sure that, last thing you want is your valve train not going where you want it to go. At that sort of RPM, as things start getting expensive, don't they, when the valves are not opening and closing when they should be. So we went with solid lifters instead of hydraulic lifters, and then the solid cams as well.
Yeah, so a trick with that is the profile of the cam itself is actually different between a mechanical and a hydraulic lifter arrangement. So you do have to match the cam profile to the style of valve train that you're running. Just to dig into this a little bit more, because this is obviously near and dear to my heart, how did you actually do that solid lifter conversion? Because there's a variety of options. There are a couple of manufacturers making screw adjustable drop-in lifters, or the other technique, which is what I used, is basically gutting the stock lifter and making up a solid spacer that went in between.
Yeah, I actually bought a kit, Andre, a proven kit, Norris Designs in the UK. So and they're a screw type, with a locking nut.
Interesting. So I had a very bad experience with that style. Oh, just in defense of Simon Norris, past guest, it wasn't one of his products. But one of the issues with a mechanical lifter arrangement is, of course, the relatively high in maintenance, in that you have to mechanically adjust the lash clearance. You might be running 8 thou clearance on the intake and maybe 10 thou on the exhaust, or something of that nature. And we have to set that and then maintain it and adjust it. So using the solid spacer, that's a real time-consuming process, and essentially you need a way of kind of linishing material off that, or surfacing material off that, to get the clearance where you need it. So these adjustable ones I thought were a perfect solution, and they seemed on face value to be exactly that. We put those into an Evo 9 we built for a customer that actually ended up with the Evo 9 world record. And to start with, the customer had come out of a 14-second Nissan Primera, so he was definitely jumping in the deep end. And we had a lot of problems initially, just sort of getting him up to speed with something that now produced 1,000 horsepower and was capable of running deep in the 8s. And, that's absolutely understandable as well. It's a big difference. But suffice to say, he spent a lot of time initially on the limiter. And that's not good for just about anything when that limiter is 10,500. And, the final straw for me was, after a prolonged sort of period on the limiter in second or third gear at our local drag strip, it actually broke one of these adjustable lifters. But when we pulled everything apart, it actually also backed off the locking nuts on just about every single one of them. So I kind of, at that point, I was like, the juice on this is absolutely not worth the squeeze, and went with the much more time-consuming solid mechanical shim.
Right, okay.
Obviously, you didn't have those problems, which is great.
No, and it's as we talked about earlier, when you're running at this level, you've got to check stuff,
Oh, of course.
very, very frequently. It's not a 6,000 mile service. It's, maybe do 3 runs and have a look, The arrangement with the locking nut and the screw is very similar to the K20 stuff and the K24 stuff, But you've got to be vigilant. It's got to be tight. The locking nut's got to be tight. But as you mentioned, bouncing it off a limiter, you get harmonics, and it's going to undo things. It's one of them things.
Yeah, definitely. All right, so let's sort of put a bow around this, and so we can move on to your current project. So power, boost, and what did it sort of end up? What was its PB?
So in version 1, it was around 980 horsepower. We did it on the Superflow dyno, engine dyno, so that we definitely knew, and it gave us a clear base map to start with. That was around 2.3 bar boost on UK fuel. We then pour it on race fuel and set it up to about 2.8 bar, and that's when it made the 980 at 10,000 RPM. If you've ever seen sparks come off a Superfloor dyno, I do have a video somewhere. The ring gear on the Superfloor dyno wasn't impressed with the RPM, but it survived just. And then version 2, it did about 1060 wheel horsepower with a turbo change. As we mentioned previously, UK drag strip preparation's probably not the best. I never managed to get it in the 8s. I got it down to 9.13 at around 163 miles an hour.
Yeah, I mean, track prep, once you're sort of talking these power levels, becomes just so critical to getting the results that you're capable of. I mean, 1,000 horsepower in a well-prepped Evo should absolutely be capable of going to the 8s. And I mean, we made a point actually with that Evo 9 that I referenced before. I think kind of learning from the mistakes I made with my own Evo 3, where all I wanted was the biggest number I could get out of the thing. And that was always our drive, was let's make more power than the next guy, and that's how we'll be fastest. And to a degree, I mean, it did work. We held the world record. It went 8.2 at 180 mile an hour. But it's a very, very hard way of getting the car down the strip and incredibly difficult for the drivetrain. And case in point, I think probably if I looked back, we would have averaged 1 out of every 5 passes, it would make the finish line. And the rest of the time, you would either have to abort the pass or something would break. And I mean, that gets super frustrating. So with the Evo 9, we made the conscious decision to cap the power at 1,000 horsepower. I think it actually made 1,001 wheel horsepower at 42 PSI of boost or something like that. And that was it. We just left it there and then concentrated on getting the car to 60 foot and getting it to go down the strip. The other reason was for the class that car raced in here in New Zealand, we were actually limited on tyre size. So, if we made 1,200 wheel horsepower, probably we would have struggled to get it to the track anyway. But that car, for the most part, incredibly reliable. It'd just do laps, which is obviously what you want to get out of it. In terms of that prep as well, I think there's a big disconnect between what you get at a drag strip for a major meeting versus what you get on a sort of a club level meeting. Has that been your experience as well?
Yeah, absolutely. Yeah. When you've got like a huge event at a drag strip and you're going to get 10,000 visitors and, the money goes into the prep and it's not just 60 foot, it's probably most of the way down the strip. And a test and tune day or a run what you brung day where road cars with treaded tyres are there and they're going to pull all the prep up. They just don't put the prep in there. And I was finding the drag car, in the first season, it was a manual H pattern box, and I was going into third gear and it was going sideways. And, it is daunting. You're correct with what you said about the 9 that you built for the driver. People look at drag racing and think, oh, it doesn't look very interesting. But I can assure you, when you're in the car that weighs 980 kilos, has got 980 horsepower, you spend most of your time steering to try and keep it in a straight line. It's it's quite exhilarating. It was as close to the bike, as I could possibly get, really.
Yeah, I think that's a false expectation that a lot of people that haven't been involved in drag racing have. I mean, hey, you're driving in a straight line for 400 meters. How hard can it be?
Yeah.
and granted, when you're doing 11, 12, 13 second quarters, it's not that difficult to keep the car in a straight line. But when you're down in the 8s with a 4-wheel drive Evo, it's interesting when the car's sort of walking all around the track between the center line and the wall at sort of 160, 170 mile an hour, and you're driving with one hand on the steering wheel because the other's ready to pull the chute. That's there's a lot going on there. There is a little bit of driver skill involved, I can assure people.
Yeah, it's exhilarating. And it's definitely worth trying. I'd recommend it.
Yeah. I think for me, it got to a point as well with the drag racing. We'd set a world record. We'd kind of done more than we set out to achieve. And I kind of got to a point where the reliability of the car, which I kind of referenced before, became just such a frustration for me. And literally after however many years we'd been developing and racing that car, I just got to a point where I was sick to death of spending more and more money on the car in order to spend less and less time in the driver's seat, which is kind of the paradox of drag racing versus circuit or road racing, where you actually are getting substantial amounts of seat time. So, these days I kind of get my thrills in a different way. Yeah, the car's much slower in a straight line, but that doesn't make it any less fun to drive.
Yeah, I suppose it was a very similar thing, Andrea. It was a 3.5 hour trip for me to get to the strip, and 3.5 hours home. And the seat time was, some days you'd only get 4 runs. If it was a typical run, what you brung type meeting, you'd be queuing in the staging lanes most of the day. And then I think it was the second season, and then the clutch let go. And I got the same as you. It was, right, I've had enough now, of spending seat time relative to cost and putting into it. So plus I'd had a job offer for overseas. So I think that was, the final curtain really.
Yeah, okay. But you weren't done here. So let's sort of fast forward to your current car, which is kind of how I ended up finding you on Instagram. Still Mitsubishi Evo diehard. So talk us through the concept and how this particular project came to be.
So the project came to be, we mentioned the drag car before, is basically what happened was I took a job overseas and I knew when I was going. So I stripped the drag car, sold all the parts off, but I had in my mind that it'd be really fun with a different engine under the hood. So when I stripped the shell, before I sold the shell, I measured the engine bay. No laser scanning, nothing fancy.
Just the old-fashioned tape measure and a pencil.
Tape measure out, front to back, width between the strut towers, heights of the bulkhead, etc., and the centre lines of the drive shafts before the engine came out off the floor. So I had a rough idea. And I wrote it down. And I took all the measurements and made a drawing, and I tucked it away because I thought, I'll be back in the future. And basically that's what happened. I was overseas. I had a rough idea of when I would be coming home, and my mind started to wander, and I started to look around for what the engine could be, possibly.
So, spoiler alert, you settled on the Sans VR38, the engine in the R35 GT-R. What other engines made the shortlist, and how did you sort of come to the conclusion that the VR38 was the winner?
I actually bought a Mercedes engine before the VR38, a 6.3 litre Mercedes engine, because I thought, well, that'll be different.
Definitely would have been that.
However, when I started looking into the parts, there was very, very little available for them. So suddenly it became very, very custom. And when you start having to have custom headwork, custom valves, custom pistons, rods, cranks, etc., it starts getting very, very expensive. So the engine was very, very tall as well, which was another issue. Once I got the engine on the stand and we looked at the height of it, it would have caused a problem with the bonnet or the hood. So I had the option to return the engine. So I did. I contacted a colleague of mine who has a GT-R tuning shop and just asked him to take a few rudimentary measurements of a VR38 that he had sat on a stand. I did some calculations and discovered it would fit very nicely in terms of the shape, the centre line for the drive shafts and the front diff.
So you obviously, with the VR38, had the ability to, we'll talk a bit more about this, but with relative ease, retain four-wheel drive, because obviously the R35 GT-R is also four-wheel drive, and you've got that differential essentially in the sump. But you've also converted from a transverse installation where the engine runs across the chassis to a longitudinal where it's now north-south, front to back. It obviously fits, but to me that would sound like a major fabrication job. How much is actually involved in fitting it?
Yeah, it was. Very much so. So the front subframe on a transverse, on an Evo with a normal transverse engine layout wouldn't work. It's just the wrong shape and the rack's in the wrong place, the steering rack. So I reached out to a colleague in New Zealand, Rob at Racefab, who I'd had dealings with before. Great guy, very helpful, some great products, great prices, and he ships everywhere.
Pretty well known for subframes and suspension arms and all sorts of bits in the Evo community, as well as a bunch of others.
Yeah, and a genuinely nice guy as well. He's very friendly. We've become friends since. I mentioned my crazy idea to him, and he offered up straight away. He said, "Conrad, I'll make you an Evo front subframe that would suit a transverse engine and gearbox, a longitudinal engine and gearbox layout." He said, "It'd be just bare for starters. I'll put you some rack mounts on, but you're probably going to have to adjust them." So he sent me the front frame and the arms, because I got the arms as well. And again, when we got the engine into the bay, the rack was a problem. It still was a problem. So we had to modify the frame that Rob had done, which we knew. We knew it was not going to be easy.
Difficult to do a thorough job of this for something that's never been done before, remotely, literally from the opposite side of the world. And also without, a 3D scan and CAD. So, yeah, no shade on Rob there for maybe not getting it right first time. I guess the next time he's got a customer rings up for a VR38 cross member for an Evo 8 or Evo 9 or whatever it might be, he'll be right onto it.
Yeah, absolutely, and I wouldn't have any qualms about sending it back for him to copy. But we basically, the frame was there; it just needed the rack mounts altering and the anti-roll bar mounts and stuff, for the front. So that was all good. But then, so that was the front end, and he also made me. I knew the rear diff and Evo was not going to take the torque levels that you get out of a boosted built VR38. So I needed an alternative. So again, I spoke to Rob. He was very helpful, and he came up with a diff that would work. And basically said, "Do you want me to produce you the rear frame that he makes for an Evo? Would you like me to produce you the frame and with this diff?" And I went, "Even better, Rob. Fantastic."
Yeah. Make it as easy for you as you can. I'm interested, obviously, with a four-wheel drive installation, we need to be a little bit more mindful about the differentials in terms of the diff ratios and making sure that we're matched front to rear. What was the rear diff that you chose, and was that problematic, finding something where you could get suitable ratios?
So there's a little story behind that. So I ended up with a problem. When the car was built and I had it on the dyno, we found a problem. And the problem was there was a slight difference in the ratios front to rear, and the car was hopping. Initial conversations with the gearbox manufacturer, something was missed. What we didn't realise in the VR38 stock transmission, the GR6 transmission, was there was a pair of drop gears in there. So when I ordered the manual transmission, we'd miscalculated on the difference between the front and rear ratios.
Right, okay.
So I ended up having to have a custom crown wheel and pinion made for the front diff.
I mean, that sounds expensive.
It was ridiculously expensive. They were made by a company in Scotland for me. Fantastic, all CAD CAM driven, great stuff, about 6 to 8 weeks. But amazing, they was all treated and super finished and cryo and everything here.
I'm interested just with obviously how many people are getting great results with the GR6 DCT transmission in the GT-R drag and roll racing world. Now, obviously, these still come with an expensive build from the likes of Sheptrans or others out there. It's no joke if you want them to hold together, but they can do that. This is a transaxle that's mounted in the rear, and then a prop shaft between the engine and the transmission. I mean, was it ever even considered to run the GR6 transmission? Obviously, complexities in terms of the electronic control, and obviously probably a lot more fabrication in terms of what you'd need to cut out. But yeah, did that ever cross your mind?
Initially, before we commenced fabrication, I did look at the GR6. You had the likes of Andy Forrest that was putting it into his Subaru. But again, as you mentioned, it was the complexities of the electronics, the ECU you had to use, because it's all torque-based, transmission ECUs, etc., etc. And it was already taking a lot longer than I'd hoped. So I figured a sequential would be a better option. The fact that we'd gone longitudinal played a massive part in the weight balance of the car. Granted, a GR6 would have probably improved that further if we'd have mounted it in the rear. But you had all the hassle of the fuel tank and everything that were in the rear.
Yeah, it'd be a huge job. I mean, anything's possible, but some things maybe just aren't worthwhile.
Yeah, absolutely. You know, for my level of using it on the street or a few track days or, you know, the odd drag race or a top speed run, it was probably the fabrication costs and the electronics costs would have, and building the box, you know, I'd have been into probably a lot more money than I was with the current setup.
Yeah. I mean, also, I definitely don't profess to know the ins and outs of that GR6 transmission and what those who are drag racing the GT-R platform needing to go through. But you sort of end up in a situation where you're dealing with tuning the engine with whatever your ECU of choice might be there. And in the GT-R world, that's relatively limited anyway. Sort of everyone's gravitated towards Cyvex or Motec. But then you also need to reprogram the transmission control module or TCM. Obviously, the ECU and TCM need to work together as well. But, sort of most people will be using something like Ecutech to do that. But even then, I mean, standing on the start line at TX2K with dozens of 1,000+ horsepower R35 GTRs going down the track, and the number of times that sort of come up and do a burnout and then stop on the track and basically have to do the old Control-Alt-Delete and shut everything off, restart it before they could back up. Just seeing that time and time again over the course of the TX2K competition, there's obviously still some complexities in there. So something basic and mechanical, sometimes there's a time and a place for that. And I say basic and mechanical, but, let's talk about what you actually went with for the transmission.
Yeah, so I basically decided to go with a manual sequential 6-speed. So I did a bit of research and I ended up going with Hollinger. They're used in stadium super trucks, which you see, most people have seen on TV or on the internet, jumping and with the big V8 engines in. The torque limits, we discussed the torque limits, and I think Hollinger have got, it's 1,100, 1,200 foot-pounds of torque will stand, but over a 24-hour period, endurance style.
Yeah, that's one thing with the Hollinger transmissions. I mean, we run the SG3 in our 86 endurance car, and on paper that is probably kind of marginal for the torque our engine produces when it's wound right up for a qualifying lap. Absolutely fine for circulating, but I kind of talked through that situation when I was purchasing the gearbox, and Hollinger said, well, yeah, we rate that for 24-hour endurance race, so you're going to be absolutely fine. And my experience after 3 years of running that gearbox is that they are super conservative, and the gearbox has been absolutely faultless. I just couldn't be happier with it.
Yeah, absolutely. And I did mention, obviously, the built VR38 and two large size turbos. You're finding GTRs are hitting, 1,100 foot-pounds. And I'm not running it at that high, but we had to make sure everything was captured, really. And they went, it'd be no problem. If it'll hold 1,100, 1,200 foot-pounds for 24 hours continuous, then the amount of time you'll have it at 1,400 foot-pounds, it's not going to bother the gearbox.
I guess the Hollinger already had runs on the board with their transmission to suit the R32, R33 and R34 GTRs with their RD6, which is kind of a generic longitudinal 6-speed dog engagement gearbox, but then they basically adapted the Nissan transfer case off the back of it so that you had the drive component heading back out towards the front axle line.
Yeah, absolutely. And they were one of the first companies to do the bell housing for their RD6 to go onto a VR38. So that gave me the mounting solution there onto the engine. And as you mentioned, they also had the adapter plate on the back to give us the transfer case options to get the four-wheel drive set working.
In terms of that transfer case, this is hydraulically actuated in stock form. Just my own involvement with the heat treatments R32 GT-R drag car, they kind of ditched that system, and it was mechanically, literally, there was essentially a handbrake that Reese, the driver, would sort of pump up after the burnout to get enough pressure to drive the front axle line. I'm wondering how you dealt with that. Were you using any electronic trickery in terms of controlling the front rear split?
Yeah, absolutely. So there is some modifications in the transfer box. We added more preload as standard to allow not as much slip in the lower, but we have kept the hydraulic control. We're actually using an Evo hydraulic pump, which generates similar pressure to what the R32, 33 ones do. It's just a more modern pump. However, the ECU controls the pressure. So, we've got 3-axis in the ECU for adjusting the four-wheel drive, basically, based on slip, based on G, based on throttle position.
Yeah, a more modern solution to controlling if and when you're going to have torque to the front axle line.
Yeah, initially we didn't have that in the Motec in the M1 because it required a custom package. I used a full race controller at first, which was basically what it had been adapted from an R32 GT-R, if you like. The problem is I couldn't, when I was driving, I couldn't see what was going on with the four-wheel drive because it was a standalone controller. There was no display or anything like that, and I found it very, very laggy, shall we say. The car would be sideways before it kicked in.
It's interesting you say that because a colleague of ours has an R32 GT-R that we actually used for some course material, and as part of getting some promotional marketing material, we took the car to our local racetrack, Highlands Motorsport Park, and I did some laps there just to get some rolling shots and things like that. And I distinctly remember I've driven plenty of GT-Rs, but normally I'm just road testing them after a dyno session, and you might give it a full power acceleration run in third gear or something to check mixtures and knock and boost, and you call it good. I'm never pushing these cars around a corner on the street. And first time on the racetrack, and first corner I sort of came around maybe a second or a third lap. And I wouldn't say I sort of driving the car hard or 10 tenths. I mean, I came around the corner at sort of what I considered to be maybe 6 tenths pace. And next thing, as I was on corner exit, I'm sort of broadside sliding sideways up the road. I mean, nice and controllable. And I'm thinking to myself, what's all this fuss about with the GT-R platform and their four-wheel drive? I mean, an Evo would absolutely have never done this. So it was actually quite a revelation that the four-wheel drive system was that lethargic to actually bring in the front torque.
Absolutely, and on the road, Andre, it's scary.
Yeah, I can absolutely imagine.
It's proper sideways before it starts applying the clamping force in the transfer case to bring the front in.
And I think actually my memory could be wrong here, so it's a fair while ago, but when they were running those R32 GT-Rs in the Australian Touring Car Championship, which at least on this side of the world, that was where we started getting exposure to the GT-R and how good it was. And I'm pretty confident in saying that Gibson Motorsport, who prepped and ran those cars, ditched the stock Atessa four-wheel drive system and they ran a more conventional fixed split. I'm guessing probably for that very reason. Predictability is obviously so important on a racetrack.
Yeah, absolutely. My biggest issue was I couldn't see what was going on. That was the trouble. I didn't know, the split, the torque split, how much clamping pressure was being applied. So that's why we ended up going with a modified M1 package in the ECU.
And for those, I mean, we've talked about the M1 package and development license on the podcast in the past, but for those who maybe are new to this, basically the firmware inside of the ECU is the code that tells the ECU what to do with inputs and outputs. And other than that, the Motec ECU is literally just a black box with a development license. If you've got the ability or you connect with someone who can do it for you, you can write your own code to bring in features or make the ECU work in a way that no one else can do. So really kind of a case of if you can dream it, you can create it almost.
Yeah, absolutely. And I was lucky that a friend and colleague of mine, Gary Hayward from AP Tuning, he'd got a similar variable system on his Evo using his M1 ECU. So a lot of the groundwork had already been done in the package, which gave us, a good boost up, if you like. So Robbie at TDP Ireland, he's the guy that originally did the modifications to the package. So Gary just sent my package over to Robbie, and he modified my GP-R package, if you like, to add the features that we needed to get the four-wheel drive control. And then with me having a Motec dash, I've actually got pages where I can see the centre diff pressure, I can see the wheel speeds, I can see everything, and I know when it's in four-wheel drive or two-wheel drive. I have the option now to flick it into rear-wheel drive, so I can do a burnout and then put it back into four-wheel drive. I've now got a potentiometer on the steering wheel with 10 different diff settings, so I can alter how it drives. You don't want too much lockup on the road when you're on the road, because it becomes awkward going around street corners into supermarkets and things.
Yeah, definitely. I mean, the stock, going back to that R32 GT-R platform, the stock kind of mode is that it is rear-wheel drive, and then under certain conditions, then we'll start to transfer torque towards the front as and when required, only maybe a second or 2 seconds after you really wanted it, as I mentioned before. Are you predominantly the same fully rear-wheel drive until you need front torque, or are you running more of a constant four-wheel drive split?
No, I'd say it's running more of a split. It's definitely most of the time it's in four-wheel drive, probably more rear biased, but maybe a 60-40 split. It's in the tables in the ECU, so you can have it 50-50 or 60-40 or whatever you want. And additional to that, because the brakes are all fed into the ECUs, when you're braking, it can apply the four-wheel drive clamping force as well.
Sure. That's interesting. I was actually literally about to ask, for improved turn-in, I would have assumed that when you're under brakes, you probably want to open everything up so it is just rear-wheel drive, because obviously you're not under power, so the four-wheel drive element's kind of a bit of a moot point until you're at corner exit. But you're actually finding that having some four-wheel drive split under braking is beneficial.
Yeah, to be honest, I've only driven it on the street, but the whole tables are based off Gary's experience. He's done time attack and he's done various other activities. So the initial tables that are in there are based on that. But when I wind the pot down, it is going to a more road-based scenario with the diff. And you are right, the less front-wheel drive when you turn in on the car, the less understeer you've got,
I guess, though, even with infinite control via this Motec firmware, there is still, I can only guess, going to be some latency going from, let's say 0 front split to 50% front split. So where I'm going with this is, if you get to corner exit, get on the throttle, and all of a sudden the rear lights up and brakes traction, there's going to be some amount of delay before the front can kick in and kind of fix everything. So if you've kind of preempted that by already having some of that front split at corner exit, there's probably, I could see a benefit there anyway.
Yeah, I mean, there's so many inputs into it. We've got steering input in, it's got the throttle input, so it knows you've already got mechanical preload on the transfer case, so you've always got a little bit of front wheel drive as well. You've got steering input, and as you start to wind that off and then feed the throttle in, it's the table's really good. It's really, really good so far. Even driving it on the street. The other thing that's so good about the Evo is the weight distribution. With people think you put that big engine in that car and it'll be even more. If you've ever driven an Evo on circuit, they are a bit understeery. You've got from the front axle center line, you've got a lot of weight forward of that.
Yeah, well, the whole engine's essentially forward of that axle line.
The engine's forward of it, the gearbox is forward of it, the turbo kit's forward of it, and all the other components. What I've actually got in the VR38 is, of the 6 cylinders, the front 2 cylinders are forward of the axle line, and you've got the transmission behind you.
Yes, you've moved a lot of the mass sort of more central in the car.
On the corner weights, the front wheels are approximately 85 kilos a side lighter than a standard Evo layout.
Wow, yeah, that's absolutely huge. Out of interest, what's the overall weight difference? Can you give us a comparison between a 4G63 powered Evo and your VR38 powered Evo?
So my car actually weighs around 1250 kilos. So it's actually lighter than a stock Evo.
Okay. Yeah, that's pretty impressive.
Yeah. And it's as we talked about earlier, the 4G63 is a cast iron engine.
Yeah.
The VR38, even though it's a V6, is alloy and it's lighter. Yeah. It could be improved further. I put the turbos up high and forward to make them easier to change in the event of, wanting to do different disciplines, because they're all on V-bands. That could be made even better because the turbos are quite heavy. So it could be made even better by pushing them further back.
All right, we've sort of bounced around the chassis so far, so let's get back to where we started with this VR38. What was the sort of power aims when you were sort of dreaming up this project, and what was required in that VR38 to achieve it?
So I actually purchased the VR38 and had no chassis to put it in. The intention was not to build what we call a one-trick pony in the UK. I didn't just want a drag car. The preference was to have something that would drive on the street, drive on the circuit, or potentially do top speed runs if needed. So I decided to put a stroker kit into the VR38 to make it 4.1. Obviously, the more CCs we get, the better response we're going to get from whatever turbos I decided to choose. So spec the engine, bought all the parts, which was the stroker kit, the bearings, all valve train, entire valve train. Didn't go crazy on the RPM with the stroker kit. 8,000, 8,500 is about the limit, really, because of the rod ratio, the rod to stroke ratio. And then I sourced the turbos, and I'd previously had on the drag car, I'd had a 67, 66 precision, and it was very good. It did the 980 horsepower, but it was a little bit, the boost response was a little bit laggy. So I thought, bearing in mind that the Evo is going to be street based initially, so I opted for the 64 66s to try and get a little bit better response from them. Bearing in mind you've 2050cc per bank, if you like. It's still a 2 litre driving a reasonably large size turbo. So to try and keep some response there. I had all the head work done, try and improve the response as well. And then Tim Radley at Race Developments built the engine for me. He's a chap that built my drag engine as well in the Evo, meticulous. So yeah, it was all good.
And what were the results once you actually hit the dyno?
So on the mainline hub dyno at 2.05 bar, it made 1065 at the wheels or at the hubs on UK Shell V power fuel.
That's no joke on a pump fuel.
Yeah, unfortunately, in the UK, what we find sometimes is that fuel is not consistent. It depends which station you get it from.
When you're sort of pushing out that sort of power level, which I mean, admittedly, it's not a stretch for a VR38. There's plenty of VR38s making much more power than that. But when you're doing it on pump gas, you kind of usually walking a bit of a tightrope on that knock threshold. And what I generally find, and it's not always the case, there's been a few exceptions that have kind of surprised me, but what I generally find with our pump fuel here in New Zealand, and granted since I sold my shop, we have now got access to some better grades of fuel, but generally I found around about that 1.5, maybe 1.6 bar mark, so 22 to 24 PSI. About that point in most but not all applications, you'd sort of get to this situation where you would add more boost to try and make more power, but then you're creating more heat. The engine becomes more prone to knock, so you'd have to pull timing out to get rid of the detonation, and you sort of go round in circles, adding more boost, putting more heat and stress on the engine, having to remove more timing, and kind of actually not really making any more power as a result. So you kind of find that that point of diminishing returns, which, like I say, normally I kind of found 1.5 to 1.6 bar. But yeah, there were a few exceptions. It's always quite nice when you get something that's going to support 30 plus PSI of boost on pump fuel. But then also the questionable quality, are you going to get that exact same result every tank of fuel you put in the car? And I kind of also now, I'm thankful for the advances in our modern electronics, because I do rely very heavily on built-in knock control strategies and ECUs to kind of act as a bit of a safety backstop if the engine does start suffering from some detonation once it's been off the dyno.
Yeah, absolutely. And the M1 is the Motec M1 is absolutely fantastic with the knock control, and the 4 channels of different frequencies you can monitor. Aside to that, Andy, who was doing the mapping on the boost at the time, had a Plex, the latest Plex not control side by side, and you can actually see the sine waves and stuff. And we was comparing it to the Motec, and it was so good, really good. And you get the slightest sprinkle of depth, and the Motec is so fast just to pull that little bit of time. But it's like you said, you end up chasing. It's a law of diminishing returns. You push the boost, you generate more heat, you pull more time, and you don't make any more power. You're just putting the engine closer to a point it doesn't want to be.
Definitely. I think once you get a bit of experience with this, you do quickly build a sense of where the safe limit is, and when you're just wasting your time, continue to push further. I think understanding that and kind of recognizing it becomes a bit of a skill for a good tuner as well.
Yeah, absolutely. The guys, they had multiple cans of race fuel there, and they desperately tried to get me to fill it up with race fuel. In reality, the turbos on race fuel are good for, potentially 1,500 wheel horsepower, but I just didn't want to risk the engine.
Fair enough. It's always nice to be able to let it eat and see what it actually can do, but you're sort of at that point doing it for the glory of the big number on the dyno for internet bragging rights and not a lot else.
Yeah, in the pub. Yeah, exactly.
Yeah. I'm interested at this point, kind of, you really, on paper at least, no further ahead than the 4G63 that you were drag racing in terms of outright power, which again is the sort of misleading aspect of looking just at the peak number. What was the power curve like of the VR38 versus 4G63?
Oh, absolutely tremendous. The red line number was 8,500. The power curve starts from around 3,000, so it's a big area under the curve. There is a bit of a step when the turbos get going. There's a significant increase, but not enough to make it undrivable on the road. It's pretty smooth and feels almost naturally aspirated, which is what we're aiming for.
I think if you can build a combination and you give it to someone and they couldn't tell it was turbocharged, I think that really says a lot. I mean, nowhere near the numbers you're talking about, but one of our Toyota 86 development cars, which we've now moved on, that we retained the stock FA20 in that, and we built a turbo kit based on some parts from AVO in Australia, but with a Borg-Warner EFR 6758, which to me, for the power aims, which is sort of 400 wheel, that was the perfect turbo for that engine. And literally, it just felt like you'd taken the 2-litre engine out and dropped in like a 4-litre V8 or something, just a bigger, naturally aspirated engine. You could never feel the thing come on boost, and it was, it was all in by 3,200 RPM. 12-pounder boost, and it just was such a nice combination. Plus, with the location of the turbocharger and the internal recirculating valve, you couldn't hear any sort of turbo noises, so literally no one ever knew. So you've talked about the electronics in terms of the Motec ECU and Motec Dash. Any other electronics that went into the build? Are you running power distribution modules or anything like that, or conventional fuses and relays?
Yeah, the whole car. No, the whole car's was a race loom. Got PDMs in there. We've got E888 extension modules in there. I went to town with my background of control and instrumentation and automation. I basically tried to use every input within the Motec. I've got temperature sensors, pre-intercooler, post-intercooler on both sides. Fuel pressure, fuel temperature, oil pressure, oil temperature, wheel speeds, GPS, you name it. It calculates the intercooler efficiency based on temperature going in, temperature coming out, etc. It's I just got carried away with the sensors, but which is why I had to get the E888 extension module because I ran out.
Yeah.
On the wheel.
Yeah, so for those who aren't sort of up to speed with Motec electronics, that E888 is an expander for inputs, and basically you can bring a whole bunch of inputs, including thermocouples, into that, as well as additional sensors, and then it communicates back to a dash or ECU via CAN, so it just expands the capability. Just when you were talking about intercooler efficiency, one of the tests that we did with that 86 that I just mentioned with the Borg-Warner EFR 6758, that was, again, instrumented, just like you said. We were looking at pressure pre and post compressor, and we're looking at temperature pre and post compressor. And I actually wrote we were running custom firmware on that, and I was sort of teaching myself how to code and build. And I'll be very clear, I'm not great at it. The code probably looked pretty ugly, but it got the job done. But I managed to write some code to actually calculate the compressor efficiency using those sensors that I just mentioned. And it took a while on the dyno to kind of reach an equilibrium point, but the efficiency actually matched the Borg-Warner compressor map within 1 or 2%. It was actually really, really impressive. So it's quite nice to go through an exercise like that and actually get a result out the other end that worked. And if anyone is a HPA member and wants to have a look at that, there's a turbo performance webinar you can search for in our archive, which actually demonstrates that real time on the dyno. It's quite interesting. But again, we digress from here. In terms of using all of that data that you've got access to now, is this kind of just an interest aspect, or have you been using that to kind of optimize any parts of the car? Obviously, it's not really being used in competition at this point.
No, I think a lot of it, Andre, is just for me, really. It's just pulling data, and I'll drive it on the street and I'll go pull the data and see what it's doing. Like you just mentioned there, in the oil and gas industry, when I was doing the big compressors offshore, the 1 megawatt compressors, we animated exactly what you said, the compressor operating point. We also plotted the choke points and the surge lines, so we knew exactly where that compressor was operating. I haven't gone into that length of detail on my dash yet, but you might have just given me an idea.
It is really nice to be able to accurately plot exactly where you're operating on that compressor map. And I mean, we had turbo speed as well. So you've got multiple kind of ways of correlating exactly where you're operating on the compressor map, and just how close you're getting to the surge line or to choke for that matter, and whether you're kind of operating in the sweet spot of that turbocharger's efficiency. All right, so what's the sort of aim from here with the car? Is a project car ever actually finished? Is it finished, or is there more to do?
I'd say it's as finished as it's going to be with me. I'm one of those people that probably enjoys the journey of the build. When it's finished, or 99% finished, I start looking around for what's the next one, And I have previously, I've let them go and let somebody else enjoy them, or the potential of that car is huge with somebody that's got a budget to go and use it for the disciplines they want, It'll be good as a drag car, it'll be good as a circuit car. It's got a parachute mount, it's got a wing mount, it's got its ratios for top speed events. It's geared to 223 mile an hour if somebody's brave enough to have a go. I'm afraid I've got to an age where I don't fancy going 223 mile an hour.
Yeah, I think I might also be at that age. 180 mile an hour back many years ago was getting up there. That was enough for me.
Yeah, so I think in terms of where it'll go now, I think the plan is it'll probably go up for sale and somebody else will get to enjoy it. But it'll always be my baby, shall we say, because it is the only one in the world. Nobody's done it. Nobody's even attempted it. So
I mean, that is the sort of the blessing and the curse with a project like this. When you put it up for sale and someone else buys it, I mean, they're going to probably, be getting an absolute bargain in terms of when you build a car like this. Going into it that you're probably going to be recovering cents on the dollar, but we don't do these as an investment, so that's fine. But of course, the rest of the world that already knows a pretty prominent car like this, when someone else buys it, it's never really going to be viewed as their car. So that's a problem, but probably a problem for the next owner, not necessarily you. Looking back at the project now, with it at the completion level it's at, what would you say, first of all, was the biggest challenge? And secondly, if you had your time again, what would you have done differently on it?
I think the biggest challenge was keeping the four-wheel drive and overcoming them problems with the engine position and the steering rack, etc. I nearly threw the towel in when the crown wheel and pinions were different,
Yeah, as we've already discussed, that's not a cheap and easy fix.
Yeah, a lot of people early days were saying just make it rear-wheel drive, but that wasn't the idea. It was to keep the four-wheel drive. If I did it different again, I think I would probably use smaller turbos. I still think they're a little bit too big for a circuit car stroke street car. It's about what we talked about earlier, area under the curve. But I made it so that they're on V-bands. So if you wanted to drop to a precision 58, which would probably be lovely on the street, and still do 1200 horsepower, then it's an easy swap.
Yeah. That is a nice aspect of how you've mounted those turbos, V-band as you mentioned, but also high in the engine bay. Tucked down in the stock location, a turbo swap is definitely not going to be an easy job.
And the way everything's mounted underneath, there's not many pictures around of underneath. I kept it very quiet. It's all modular, so the way the gearbox, the transmission is mounted, and the engine, the front end, basically you take the front end off the car, the headlights, the front grille, radiator, etc., and the whole package comes out the front as a oneer. One of the reasons why we didn't go stock location turbos, because even on a GT-R you can't take them out, you've got to drop the engine, so I didn't want that hassle. I don't have the facilities at home to be doing that.
I think as you progress through sort of modifying cars, working on cars, and generally maintaining them, you do start to really respect modifications that are easy to work on. It's one thing just fitting a turbo to a car, which is the right turbo for the application, but you could do that in a way where replacing or working on that turbocharger is an engine out job, or where it's an absolute dream and in 15 minutes with a couple of V-bands you've got the turbo off on the workbench. So those are the things that until you've actually had to work on the car, I think it's super easy to just not even give a consideration to.
Yeah, absolutely. And I think the only other thing, I should have integrated the four-wheel drive in early doors, in revision 1 into the ECU. I avoided it initially without trying to get the ECU to be too complicated, and I went with a standalone controller, which didn't work out too well. So minor stuff, really. The length of time it took was a long time. I guess one of the major ones was I should have started with a rolling chassis, whereas I actually started with a bare shell from absolutely nothing. You live and learn, don't you? We learn from experience.
I think from my own experience with project cars, you go into them with the best of intentions of when it's going to be hitting the track or the street. And if you simply take that time frame and multiply that by maybe a factor of 3 or 4, you're probably starting to be realistic. And I say that now 3 years into a 12-month rebuild of my FJ40 with currently almost no end in sight. Maybe there's a speck of light at the end of the tunnel, but yeah, suffice to say there's still a long way to go. All right, Conrad, we'll move towards wrapping this thing up because we're starting to go a little bit long here, and I do want to respect your time. So we'll finish off with the same 3 questions we put to all of our guests, and this first one I think is probably pertinent given what we just talked about with maybe the Evo going up for sale. What's next in the future for you? I'm guessing there's got to be another project car on the horizon at some point.
It's not really a project car. Yeah, I'm going from one extreme to the other. At the minute, I'm enjoying doing track days. I'm enjoying doing track days in a little Suzuki Swift. So I've gone from 1200 horsepower to 123 horsepower, but we've been doing track days and it's immense fun. So I'm actually enjoying just driving, getting the track time at the moment.
I think there's a lot to be said for driving a slow car fast. And particularly, if you've got 6 other cars that are exactly the same spec, it's kind of easy at a track day to blow everyone into the weeds if your budget allows, just by hitting it with a lot more power and big brakes and better suspension. But it's kind of a hollow victory, I think, beating a car by 2 or 3 seconds a lap just simply because you've got 2 or 3 times the power. When you can actually beat someone on merit because you're racing against someone in exactly the same machinery, that's a lot more satisfying in my experience.
Yeah, absolutely. And it's just been fun, I've enjoyed it. I have started acquiring a few Honda parts, Honda engine parts, so we'll see what develops in the future. No idea what it's going to go into, but
K-swap Suzuki Swift.
well, it's already been done, so there's a couple around. There's one in Australia already.
Okay. So getting the sense that you like to do stuff that is one-off and unique as opposed to following a path that's already proven.
Yeah, I used to do, but it might be, with what's going on with the track days and the Swift, it might be just a case of building something that'll be fun on track, relatively low budget.
I mean, at the end of the day, that's really all that matters, is if you're having fun. And, everyone's sense of what's fun is different. So, we can't say for someone else what's right or wrong. It's as long as they've got a smile on their face, well, have at it.
Yeah, absolutely. Yeah.
All right, our next question, and obviously we're normally angling this towards someone who is hands-on in the industry, working in the industry, which you're not quite, but I think you've probably got enough runs on the board anyway. Is there any advice you'd give to a younger version of yourself to help reach where you are today in your career faster?
In your career? Yeah, I'd focus on one thing and get really good at one thing. And from there, it becomes a great stepping stone. And doors tend to open, and then you move on to the next thing and you become really good at that. I think today a lot of people tend to do too many things at once. If you focus on one thing and get really good at it and then move on to the next one, then you can build it really good. It don't matter what industry you're in.
Yeah, I think that advice, you're absolutely right, does go across the board. So totally relevant to our listeners. I've suffered this myself, and it's very easy to kind of get a certain distance down the road with a particular direction you're going in your life, and to get mastery at that skill or whatever you're trying to get on top of is a hard slog often. And I call it shiny object syndrome. It's very easy to get sidetracked by the next big thing or something that's completely different because you're sick of the slog, but you have to really be able to put that in and achieve mastery before moving on. Otherwise, you sort of get into the situation of being, jack of all trades, but master of none. So I think, very, very relevant advice. And last question for today, and I think this one's so totally relevant because obviously everyone needs to go and have a look at this AE86 and your Evo. If people want to follow you and see what you're up to, how are they best to do so?
So I'm on Instagram as Armchair Tuner. I'm also on Facebook, and there is a little YouTube channel, but it's not much on the YouTube. If people are interested in seeing a video of the car officially gassed, who are on Instagram, have been down and filmed the car a few days ago, and he's actually drove it. So there's a full video coming out on the officially gassed YouTube channel.
Okay, well, we'll look out for that as well. As usual, we'll put links to those accounts in the show notes to make it easy for people to find. Oh, look, Conrad, it's been a great couple of hours here getting to sort of see the background of what you're doing. I've followed you on Instagram for a fair while and kind of watched this Evo take shape, but obviously Instagram only gets you part of the story, so it's been nice to actually fill in all of the gaps that I had. Yeah, again, thank you for coming on the podcast. And if you do sell the car, I'm sure it'll be a real shame to see it go, but look forward to seeing what comes next.
Absolutely. Thank you very much for having me on. If anybody's got any questions, just drop me some notes and I'll try and answer them.
All right. Thanks a lot.
Thanks very much, Andrea.
If you enjoyed this episode of Tuned In with Conrad, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HP8 t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Big Ted73 from little old New Zealand, who has said, having been a follower of High Performance Academy for some time and a purchaser of more than a couple of courses, maybe 10 plus, the podcasts have reiterated the learning from the online courses. The quality of the guests and depth of information provided is next level. Well, I'm glad that you're enjoying the courses as well as the podcast, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.